Bradley Thayer, coming to you on behalf of South Mountain Community College. The course is CIS 263 Java 2. We are in week 5 discussing object-oriented programming. This week it's abstract classes and polymorphism. Chapter 8 is the chapter in your text, and in Canvas there are additional web links, and you are welcome to find more, but these are the 2 or 3 web links that I found that I thought were the most helpful. Hopefully this video will add some substance and help to what my expectations are this week in the lab. So I created, again, we're talking about abstract classes and polymorphism. I'm going to discuss the polymorphic behavior first here. So I've created this shape class, very generic, very simple. All it does, as you can see down here, is it returns I am a shape. Okay. If I have a square class that extends shape, then I can create this print area. Then of course the area of a square is the side squared. So I've got this constructor and I set the value for side and I return my area. I do a similar thing for triangle. So here I have a base and a height with a constructor, and then print area 1/2 base times height. So let's say I create this area class, and I create an instance of square and triangle, the side being 2 here, and the base and height 3 and 5. If I run this, I get what I expect. I am a square, area 4. I am a triangle, area 7.5. Now, for instance here, let's say I had hundreds of shapes. 50 squares or 150 squares, 150 triangles. Okay. Would you want to do that 300 times? I don't think so. Let's say we had squares, triangles, circles, trapezoids. Okay. Well, I could loop, right? And that's what we're going to eventually do. I can loop, but what's the problem? If I put my squares into an array and I put my triangles into an array, then I have to have multiple arrays. With that circle, with that trapezoid, with any other shape, then I have to have 3, 4 arrays. Again, it gets a little unwieldy. So what if I told you there was a way that no matter how many shapes you have and how many types of shapes you have, I can do it all with a single array. And the way I do that is I'm going to replace square here with shape, and triangle here with shape. So the way this works is square is a shape. Triangle is a shape. So I have replaced this right here, this type of that variable, the type of this variable shape, but I use the constructor from square and the constructor from triangle, and I can do that because of this relationship. Now when I print this, it should be exactly the same. You shouldn't be able to notice a difference. And there it is. So again, the real benefit now comes, no matter how many of these shapes I have, I'm able to, I'm going to comment this out, I'm able to loop over it, because I'm going to create a single array and they're going to be shapes. In this case, I'm going to put 2. So this for loop right here, it's a for loop that's slightly different in syntax from your traditional for loop, but it helps you loop over a collection of objects. So I have this collection of objects, that's the array of objects, array of shapes, and I say for each, what this means is, it's like I'm saying for each shape in my shapes, name the one you're currently looking at individual shape. I should, for singular and plural purpose, say individual shape. All right. So the first time through the loop, it's going to say the individual shape is going to be my square. The second time through, it's going to be my triangle. All right. So when I print this, you're going to get an extra space here just because of this. But the area is the same, and the identifier for what particular shape you're looking at is the same. I just added this print line in. So Java is able to figure out which constructor to use. So I can have a single for loop, and it can go over however many shapes you want to extend from the shape class. That's polymorphism. The abstract class comes in this type of setting, this type of context. I can run this right here. I think I did at the beginning of the video. Okay, I am a shape. In fact, just to make it clear here, don't want to get too far off on a tangent, just had a thought though. If I say super print area, there, do the same thing here. Now go back to area. This kind of just highlights a little more what's going on. And this prints. Okay, I am a shape, I am a square, I am a shape, I am a triangle. So no matter which one ran, it printed the print area from the superclass and the print area from each of the square class and the triangle. All right. Now going back to the shape like I was a second ago, before I interrupted myself, when I run this, I am a shape. I'm never going to have an area. There's never really going to be a print area for a shape. Shape is too abstract. There's no definition for area of a shape. It has to be something more specific. So I can put in here abstract, and right here it says I cannot instantiate. I cannot create an instance of shape. I can extend from shape and create an instance of other things, but shape itself cannot be instantiated. So it's a protection, you might say. It forces whoever's coding in the environment to honor that restriction. So all I had to do is remove the instance of shape from the main. But at this point I don't need the main either, so I just took it out. And there you go. Technically I don't even need that constructor. It could just be simply what I have here. Now when I run it, it should give me the I am a shape, I am a square, the area, and there it is. So that's the video on polymorphism and abstract classes. When you actually do your lab assignment, I'll give you this much of it. I just put a dog and a cat in. Right? You need to loop over a kennel, and the kennel is going to be an array with animals in it. And the animal, when it prints off the print animal method or whatever you may have called it, it needs to know which species, and then the age and the specific vaccine appropriate to what kind of animal it is. If you have questions, feel free to post on the discussion boards in Canvas or send me a private message. Thank you.